Welcome to Spark Science, where we explore stories of human curiosity. I'm Regina Barber DeGraff, and I'm an astrophysicist and pop culture enthusiast.
And I'm Jordan Baker, comedian, home inspector, and naturally curious person.
Joining us today in studio is Dr. Melissa Rice, planetary geologist, Western professor, and our resident Martian, which we'll talk about in a little bit, and Dr. Jim Davenport, astrophysicist and science blogger.
We're here today to talk about exoplanets. Thank you all for coming, because I want to know more about exoplanets too.
So, Melissa has been on every season. This is your third season, our third
Let's
season.
keep it going.
Congratulations.
Dr. Rice was our first guest. So, but just for our listeners, if this is new to them, I kind of want to ask you and Jim to kind of explain what you do and kind of how you got into that. Because I like to have our listeners kind of know who they're listening to. So I'm going to let Melissa go first because she's always first.
She's a pro.
Yeah.
So, I don't remember what I've said before.
That's fine.
So
That's fine.
hopefully it's consistent.
Yeah.
Hopefully it's the same story
People
every
are going
time.
back to
I got it
zero.
logged in here. I'm going to catch you.
So when
listeners,
I
yeah.
went to college, I didn't know what I really wanted to study. So I went to a liberal arts college, kind of like Western, that had a huge range of possible things I could study so that I could take the sampler platter and figure it out.
Right.
But I knew that astronomy was one of the options I was considering, along with environmental science, women's studies, biology pre-med. So I wanted to go to a place that had a telescope.
Yeah.
So I went to college and was taking some classes and eventually worked out that, yeah, this astronomy thing is pretty cool.
So what is your research now, just to kind of add on to that?
Yeah, so when I was in college, decided on astronomy. At the very end of college, realized that there was this place called Mars. And, well, let's say
how it
my
happens.
astronomy education was not so bad up to that point
Yeah.
that it took me to my senior year to realize there was a place called Mars.
Yeah.
But it did take me to my senior year to realize was that Mars was not just a planet, but a world. Mm-hmm. It had geology, it had landscapes, it had all sorts of things that I had experience with here on Earth. And so unlike things like black holes, pulsars, galaxies, nebulae, they weren't just theoretical constructs. Mars was a place that I could have some kind of resonance with my own experience as a person on a planet. So I was like, hey, that's cool. I figured out Mars was where it was at, went to grad school to work with the Mars Rover program, which was being operated out of Cornell University. So went there for my PhD, and just so happened, by the time I was finishing my PhD, that was when the Curiosity rover was about to land. So timing worked out really well for me to graduate and go work for the new rover mission, the Curiosity rover. And then got a job up here at Western, and NASA allowed me to stay affiliated with the Curiosity rover mission, so I can still do that, but from here in Bellingham.
I'm going to bring it back to Jim, and he's going to talk about his background a little bit. We've been talking about like non-stereotypical, like how you get into science, how you got your PhD, that kind of stuff. And since I've known you for a while, it's not like this exact same story as a lot of the faculty here,
Okay.
I would say.
Cool.
Is that an insult? I don't know.
No, I mean, it's cool to be unique.
Yeah, sure it is. No.
So when sort of to mirror what Melissa was saying, when I was 18 going off to college, I was 18, so I was totally convinced I knew what I was going to do. And I was going to be an astronaut. That was like my goal.
And that's what you wanted since you were like baby?
Since I was like a kid, like I watched way too many versions of Apollo 13, like wore that VHS tape out. So I went to college. I was totally convinced, being 18, that I was like, I know what I'm going to do. I'm going to be an astronaut. I'm going to be an aerospace engineer, because that sounded like how you get to space. Was you build a spaceship.
Well, you build it and then you get in it.
Right.
That was your thought process.
So,
Okay.
you look at the resumes of people who have astronaut as their job
Right.
title, and like a bunch of them are engineers.
A lot of them are pilots too.
Well, that was not in the cards.
Okay.
You do the college wander around thing. So I also went to a big school. In the meanwhile, I was taking sort of science and math classes, knowing it was going to be somewhere in the sciences and math field that I wanted to land, and took intro astronomy class. And then my girlfriend at the time, who became my wife, also took, separate from me, an astronomy class. Just intro, we call it Astronomy 101. And I was like, wow, this astronomy thing actually is awesome, and maybe I should check this out. And so I took a few more classes, joined the major, And then got like super sold on it. Was like, yeah, this is it. I'm gonna be an astronomer. Like I figured it out. So I'm looking at the career path. Like, how am I gonna be an astronaut being an astronomer? And I got to apply to grad school. I got to get a PhD because that's how you be an astronomer.
Right.
Thus, I can be an astronaut. Got to be a PhD. So I applied to all these grad schools and didn't get in to any of them.
Yeah.
And that was an expensive and
that's when I met you.
right. Well, it was right after that. And
Oh, you applied to 11.
yeah, right. 11. I cast a wide net and just got completely knocked down.
Yeah.
And that forced me to, so this is sort of the, I guess, non-traditional part, or just the real life part.
Yeah.
It forced me to really think about, okay, what am I going to do? You know,
Yeah.
I was like a mediocre student in the end of it,
Yeah.
who just got really stoked about science, but not about doing his homework.
Right.
And I ended up at a terminal master's program, so meaning
You're gonna
only
die.
kind of.
Yeah.
Meaning only 2-year program, only master's. There's
Yeah.
no chance of going on. Of course, you know this.
Yeah.
And
So.
here's the tie-in. Yeah. So here's where the action is. So my research focuses not on the data that the Trappist system was discovered in, but instead I focus on data from the NASA Kepler mission. So Kepler was explicitly designed as an exoplanet hunting telescope. Kepler stares at the same patch of sky, and what it's looking for is a planet passing in front of its parent star. So
Right.
passing between us and the parent star.
Right.
And when it does that, it blocks out a very small amount of light.
Right.
This we call a transit or an eclipse.
So is the Trappist? Are they not using?
They are.
They
yeah.
are. Okay.
So
the
they
same
just-
kind of method.
They just didn't do it. So Trappist was outside of the standard Kepler field. Kepler, picked one field and had to stay there. And Trappist, by total circumstance of luck and good planning, was able to fall into one of those fields. So why I'm excited about Trappist is a few weeks ago, NASA released, and they do this every quarter, but they did this extra fast for Trappist, knowing that it was exciting, knowing that a lot of people were wanting to get more data on Trappist.
Yeah.
They released publicly, and you can go online and see the data for yourself, a whole 90-day, or it's like 75-day chunk of data on the Trappist system from Kepler. We call it K2 because it's the second version of Kepler.
Right.
And so that's where I get
rotating
excited
version.
about it. I study the stars behind the planets.
Okay. Let's talk about this famous announcement that came out recently, the Trappist-1 announcement. So we all have kind of a minimal, or I have a minimal understanding about this announcement, but I'm going to let you or Melissa kind of take it away of what was this announcement and why is it so exciting?
Cool. So, okay, I'll talk about Trappist.
Yeah, let's do
Please.
it.
So Trappist stands for Transiting Planets and Planetesimals Small Telescope. So these are like mini proto-baby planets.
Proto-baby planet.
Yeah, so we think
Sure.
the formation of the solar system, planets swapping places, things running into each other. These big early proto-planetary things are called planetesimals, or like small objects. The Trappist star has a really long telephone number for a name, like 2 mass J1823, blah, 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 like 20 digits long. And
Right.
it got shortened to Trappist because the star was first observed with the Trappist telescope. So Trappist-1 was the first star observed by the Trappist program that they found 2 planets around. Yeah, so they have 2 planets, so Trappist-1 B and C.
Okay.
So these are the 2 planets they first discovered. And so then they followed up the system for years and years and years with Spitzer Space Telescope data, with, I think, Hubble Space Telescope. And they discovered, in the Spitzer data, which is infrared,
Yeah.
they discovered 6 other planets.
Right.
So a total of, 5 other planets. So a total of
5
7 planets total, yeah. And where one of the planets, they only had like a partial orbit. They only had like 1 or 2 transits.
So they had a little, like, sort of data for one of these planets.
Right, so sort of data for one of these planets. So they knew there were 7 planets, at least. And this is really exciting. This is the first system where, besides the sun, where we know there are at least 7 planets. So in our solar system, we know there are 8 planets. It used to be 9.
Right. We can get into
Let's
that
not talk
later.
about the controversy.
Yeah.
I think
We're
we
not a
should,
controversial show.
I think we should
We
teach
are.
controversy.
Yeah. We'll hit.
That's a different episode.
Yeah.
So they killed Pluto.
Yeah.
And,
You're like, we're not going to talk about controversy.
but it's
Killed
dead.
Pluto.
But it's dead.
Yeah.
So
It no longer exists.
So we know we need to be able to form planets like this around other stars for
Yeah.
life like we know it to be common.
Right.
So this is the first planet system that has at least 7 planets, which is really cool. It's like a new record for number of planets around a single star.
What was the old record?
It was like 5, maybe 6.
It's pretty good.
It's pretty good.
Well,
it's no
right?
slouch.
Like-
5 is pretty good.
Yeah, right?
It's a lot. What are you gonna do with 5 planets?
I don't know.
Lots.
We could do something.
Yeah.
Right?
Well, I mean, so from what I watched and read about it, the other cool thing about this system is that there are a fair amount of planets inside the habitable zone. So I'm going to throw my question to Melissa now. So once we have those 3 planets in the habitable zone, now we have planets like Mars, which you study, and we have maybe we could have Earth, maybe we can have things with water, right?
Yeah, so first let's define what a habitable zone is.
Yes.
So it's basically what it sounds like, the zone in which we think planetary surfaces might be inhabitable. So that doesn't mean that they're inhabited. We're not making the leap to say that ET exists on any of these planets yet.
Right.
But
It's the 4th one.
it's theoretically...
Yeah.
Sorry.
So we have this way of estimating which of these planets might be habitable. And by that, we just mean that liquid water theoretically could be stable on the surface.
Right.
So planets that are too close to the star are too close to be in the habitable zone because they're too hot and any water on the surface would boil away. So Venus is in that situation in our solar system. Planets that are too far away from the star, any water that would be on the surface would be frozen all the time. We don't think that's a place where life can really thrive and take hold, so that is outside the habitable zone. And Mars right now in our solar system is just on the edge of that.
Okay.
So in our solar system, aliens in the Trappist planets looking at us would probably guess that Earth would be the inhabited planet because we are in that habitable zone. Some people call it the Goldilocks zone or the sweet spot.
Right.
So
Sweet
how
spot.
many,
Yeah.
Jim, I forget how many of the Trappist planets are in this classic habitable
So
zone.
in the classic habitable zone, it's 3,
Right.
as Regina said. So something like 3 of them, one's sort of on the inner edge, one's in the middle, and one's on the outer edge.
Right.
Like us, it's like looking in a mirror.
That's right. What I think is important to remember, though, is this star is very small. This is what's called a cool dwarf, an M dwarf, we call
Which
it.
is what you studied
Which is what I
in
studied,
graduate
right.
school.
So this star is much smaller than the sun, and so we have to shrink the habitable zone accordingly, right?
okay.
If you make the fire smaller, you got to move in closer
To the campfire,
to the campfire to stay warm, right? So the same analogy goes with the habitable zone. As you make the star small, like 10% or 12% the mass of the sun, it's
that's
really
really
small. It's a
small.
really small
Oh,
star. It's like
wow.
10%.
So how big are the planets?
So the planets we do think,
question.
the planets are roughly Earth or Mars sized. So they appear to be the right size for
So they have to be
Earth-like
really
planets.
close.
But they're really close, right? These things have a year, so their entire orbit around the star. A year for these guys is like 10 days, 12 days. The longest one is
Our
something
days.
like 18 days.
Yeah.
18 days to go all the way around the star, which gives you an idea how close they are. They're right up close to the star. So while there's still a lot of planets, and they are the right size, we think, to be rocky, Earth-like or Mars-like planets, they're really close to the star. So there's some different rules that may apply here in terms of what we call habitable. So the classic habitable zone is 3 planets. Whether any of them are actually habitable, I think, is another interesting question.
Right, they're showing these artist renditions of these planets, and they're all
Right. We have some of those here.
they all look like variations of the Earth.
Yeah.
The artist renderings, they have various amounts of water on the surface, clouds, rocky bits, but we have no idea what these planets are made of, right? We don't even know for sure that they have solid surfaces, although they're in close enough to their star. They probably formed from rocky and metal bits, and they probably have solid surfaces. But we have no idea if they have atmospheres. We
Yeah.
have no idea if there is water on the surface to even be in a liquid form.
Or if they have magnetic fields, so that to keep them protected from radiation, right?
Right. So I think that a lot of the wild speculation that you see in news stories and blogs online, that's wishful thinking. And there's definitely the potential for these guys to be habitable, but we have no idea. All we know is that they are in this theoretical spot. And what we're learning from the exploration of our own solar system is that you don't have to just be in this classical habitable zone that's the right distance from your campfire. That the habitable zone doesn't necessarily have to be a sweet spot distance from the sun, but maybe the habitable zone is a sweet spot distance beneath the surface of a planet. So in our own solar system, aside from Earth, the only places we think might be inhabitable today are the icy moons in the outer solar system, way outside of this classic habitable zone, that are places where there might be oceans underneath the surface.
Right, like Europa.
Like
My
Europa.
favorite moon ever.
Yeah. So some of these Trappist planets that might be outside the habitable zone, they're not getting as much love or talk today. Maybe those are the ones that are actually habitable because they have water, maybe not on the surface, but deeper underneath.
I think it's also important to remember that these stars aren't eternal, aren't constant over all time. And so in the past, Trappist, the star, was probably a lot hotter. And so if these planets have been in the same location the whole time, they may have been uninhabitable, and as Trappist has cooled on sort of its main lifetime, its main sequence lifetime, they may now technically be in the habitable zone. So this outer planet may have been the sweet spot, and now that habitable zone has sort of walked inwards as the star has cooled.
Yeah.
Or on the flip side, planets move around
Right.
too.
Yeah.
So we can't assume that these planets have always been in this order of 1, 2, 3, 4, 5, 6, 7 their entire period. They
Could
switch
have all
places.
been Pluto's.
They could.
Well, I mean,
Just gonna
Planetary
kill 'em.
migration is an ongoing field right now.
Let's talk about planetary migration, because that I don't understand at all. I mean, like, for any of the classes I've taken in undergrad and in grad school, it was like it gets hit by something and then it moves, or it has a really, really wonky orbit. Is there other explanations for planetary movement in a solar system?
Yeah, there are models of planetary migration and planets swapping places within our own solar system,
Like, wow.
just from gravitational interactions.
Oh, wow.
And the physics of that is beyond anything I can
Okay.
describe here, let alone even understand.
And it would be a
But-
slow process, though. We're not talking like a giant asteroid comes in, knocks it out, and, you know.
So in geological
billiards.
timescales, it would still be, a fast, catastrophic thing.
Oh, okay.
Very soon after the formation of the planets.
Oh, got it. Okay.
So there is a model where planets in our own solar system, the large gas giant planets, have switched places, and that through the gravitational interactions of those planets switching places, they basically create chaos in the outer solar system, fling any small asteroid-sized bodies or planets that haven't quite formed yet, fling some of them to the inner solar system. They bombard the surface of the moon and Mars and the surface of the Earth, and maybe wreak havoc for early life forms just starting to take hold. And we actually have a record of this. This would have been way before the dinosaurs, though. This would have been
when it's being
their
made.
bacterial ancestors.
Okay.
Yeah. But we do have this record on the moon of this one period in time when it seemed like the moon was just getting pummeled all at once. And so one explanation for this, called the late heavy bombardment, this period when the moon was just being pummeled by all these things at once, is this is when planetary migration was occurring way out in the outer solar system, flinging things in to the inner solar system and banging up the moon. And then at the same time, things could have also been flung out to the far reaches of the solar system. And maybe that's a way to get Kuiper Belt objects so far away and things into even the Oort cloud. So planetary migration can F stuff up.
Is that why the moon looks like Swiss cheese? Because it has a bunch of dents all over it?
Yeah, exactly. It's just busted up. It's been
Yep.
Been
beat
hurt.
up and
It's been
pummeled.
hurt.
Yeah.
It's been hurt.
It was the
proves that
nerd
I-
of the solar system.
Well, this proves
Shoved
that
into a locker.
I never took planetary geology. Like, all of my astronomy classes were like not about the planets at all. But you were going to add something. So.
I was going to add just that, as Melissa's saying, the moon took a beating, but so did the Earth.
Yeah.
Right? The Earth would have had to have taken that same beating. You just don't see it anymore because oceans and wind and what we call weather.
So I'm going to open this up then to basically let's ask questions and let's pretend let's theorize about this system. So now we've entered the realm in which this is not totally data-based, but kind of. So I'm going to throw it over to Melissa. So with this smaller star with possibly these three objects in the habitable zone, like what would be the most awesome thing that we could find? Like what would be a really great scenario, and how could we find that? Like you said, we don't know if they have atmospheres. Like how do we find that? If it did, what would that would tell us?
Well, the frustrating thing right now is that we can make all the speculations we want.
Yeah.
But the data that Trappist might continue to collect, the data that K2 is releasing, it's not going to tell us what is actually on the surfaces of those planets.
Right.
So I think the next big advance in exoplanet science that's going to happen, that's going to give us some of these hints, is when we can start actually detecting planetary atmospheres. So we can look at the sunlight that is passing through the edge of the planet, which would pass through some of that atmosphere, and we'd see what gases in the planet's atmosphere are absorbing different wavelengths of sunlight. And there are things we can look for when we start to get that kind of data, which is going to require a lot of sensitivity. But when we can start seeing that, we can start looking for things in the atmosphere that don't occur, well, I was going to say naturally, but don't occur without life. So things like a lot of oxygen in the atmosphere, like the Earth has. If we weren't here, we being life and all of everything within the tree of life, if we weren't here on the planet, the Earth would not have an oxygen atmosphere. We would not have this 20% O2 in our atmosphere. That is essentially green things constantly pumping oxygen into the atmosphere. And so there has to be some kind of life form to keep the atmosphere in what would not be a natural atmosphere equilibrium state. So if we look at one of these Trappist planets and we see a strong oxygen signal in its atmosphere, that would be really exciting because that could be a nice fingerprint for life. Also, if we see a lot of water vapor in the atmosphere, that might be a hint that the water vapor is evaporating from big bodies of water on the surface. That maybe some of that water vapor is raining out on the surface. That maybe these planets that are in the habitable zone might actually have water for life to inhabit. So those are some of the things that would be really exciting to find that we actually have a chance of learning in our lifetime.
So, but you're saying that there's nothing that we have now that can do that, that has the sensitivity that can actually get that light going through that atmosphere and analyzing that, or do we?
Yeah, I don't think so, Jim.
I think it's been done for a handful of planets around brighter stars than Trappist. Trappist is quite faint.
Okay.
And so for some of the nearby brighter stars where the signal is stronger, I think it's been done. I think Hubble Space Telescope has been one of the places it's been done. But these features that Melissa's talking about are largely in the infrared. They're easiest to see in the infrared. And for that, we need an infrared telescope. And so for that, NASA is building, and in a year and a half is launching the James Webb Space Telescope, which is essentially the successor to Hubble. And its main goal is to look at planets like Trappist.
Oh, wow. What about objects that have atmospheres here in our solar system? There's us.
Yeah.
But for Melissa, what other objects in our solar system have atmospheres?
So not many.
Yeah.
Atmospheres are pretty rare. Venus has an atmosphere. The problem is it has too much atmosphere. Its atmosphere is about 90 times denser than ours, which means greenhouse gases, the greenhouse effect is out of control. Surface of Venus hot enough to melt lead. That's not the kind of atmosphere we want to really find on these Trappist planets if we're interested in life.
Right.
Mars has an atmosphere. It's just really thin right now. Mars's atmosphere is almost purely carbon dioxide. And so you'd think all that CO2 in its atmosphere, greenhouse effect must be a thing. But it has too little atmosphere for the greenhouse effect to really warm its surface. Mars's atmosphere is 100 times thinner than Earth's atmosphere. So Earth, Mars, and Venus are kind of the Goldilocks planets. One's too hot for life, one's too cold for life, too much atmosphere, not enough atmosphere, but the Earth is right in the middle. So the Earth is the only planet that has an atmosphere that can sustain life as we know it and can sustain liquid water. On Mars, the atmosphere is too thin for liquid water to even be theoretically possible. Even if the temperatures warmed up on Mars, there's just not enough pressure to sustain water in the liquid stage. Water behaves like CO2 does here on the Earth. So water would look like dry ice does here on Earth, where it goes directly from a solid block and it starts vaporizing into a gas.
Wow.
So if you try and melt a chunk of dry ice into liquid carbon dioxide, you can't do it. You heat it up, and it just goes straight to gas. That's because carbon dioxide requires higher pressures to be a liquid. Water requires higher pressures than are present on Mars to be a liquid. So that's a problem. But then, so we think about, okay, the atmospheric pressure that you need to sustain liquid water. Well, what if life doesn't even have to have water? What if it just needs some kind of solvent, some kind of liquid? That opens up all sorts of other possibilities. So we've got this moon of Saturn called Titan.
I was just gonna
Yeah.
like, what about Titan?
So Titan has a more Earth-like atmosphere in its amount of atmosphere and the pressure of atmosphere. But Titan does not have an atmosphere that is made up of the same stuff as us. Titan's atmosphere is hydrocarbons, methane and ethane. So much different kind of atmosphere. And on Titan, it's super, super cold because it's out at Saturn's orbit, far, far away from the sun. And water is present on the surface, but it's frozen solid. Water is the rock. Mountains are made of water ice. It's a pretty wild place. But there's liquid on Titan that the atmospheric pressure can sustain, and it's liquid hydrocarbons.
Yeah.
So methane and ethane lakes and rain and rivers. So
and it has like weather.
Yeah.
Yeah.
So that's how, I guess, my work as someone who studies planets specifically in this solar system gets translated into more of this exoplanet science. Once we start learning about other weird things that are present in our own solar system, that opens up all these possibilities for even weirder things might exist out there in the Trappist system. If we know that liquid methane ethane is present here in our own solar system, what other liquids might be present over there that could have life emerging in totally different ways than we're even able to imagine here on Earth?
That is awesome.
I was thinking, water is sort of a precious resource that we like to have here, and people are always going for the next water thing, spring water and city tap water. What if somebody goes to Titan and opens up a water factory, bringing in all the frozen chunks here, melting it down, and then selling it? You think that could be giving people superpowers?
Yeah. I think that is going to be the next trend among Hollywood divas.
Yeah, I just throwing
Titan
it
water.
out there. Maybe
Titan water,
if
yeah.
somebody wants to, that's
Tom
my
Hanks?
idea.
We've already
If
talked
my
to Tom
idea
Hanks, so.
is patented. Just
He can give
give
you
me the
money for it.
royalties or whatever.
Asteroid mining is kind of an up-and-coming thing, so
That's a real
Armageddon,
thing.
we all saw
why
it.
not mine water elsewhere?
Yeah,
Yeah.
yeah. Well,
Hey, whatever gets us onto the surface of Titan.
right.
If it's a bunch of water mining
You'll
corporate
take it.
people, go for it.
Well, I mean, because we've actually talked about this idea, and I don't know if it was on our Pluto show when we had that public event, but we were talking about this like mission to Titan where it was going to be a boat and it was going to like sail in these methane seas.
Yeah.
So what happened to that mission?
So that was
Proposed
one.
mission.
That was a proposal for a funding program that has since gone through its process of selection, and the Titan boat was not one of the finalists.
What is happening?
Yeah, I know. We're all that angry, but inside.
Space boat.
Yeah, I know, right? The
Who said
space
no to a
boat.
space boat?
What was picked instead?
So there are two missions going with the Discovery program.
Yeah.
One is going to an asteroid, a metallic asteroid. It's like a big hunk of metal.
Still not better.
No.
Not as
we
cool.
already know
No.
it's a big hunk of metal.
Yeah.
Big hunk of metal. And another's going to a Trojan asteroid, which is a big hunk of rock.
See, I think they should have diversified there.
Dumb. Yeah.
Yeah.
But it's in the shape of a horse.
Thought it was in the shape of a condom.
You'd be wrong.
It's round.
You'd be
It's
right.
round.
It's a safe space.
It is a safe place. So like, we could have a whole show on like missions and how they don't get funded. But I want to bring it back to like these speculations, because we were talking about it would be great if it could be like Earth, but like you were saying, even in these outer regions, there could be moons like Titan, and we should like kind of pay attention to that as well and speculate on that. But I think Jim was talking about his work talks about flares and sunspots, and that can also affect this Goldilocks region.
Yeah, that's right. So Trappist, being a small star, has a slightly different, the star itself has a slightly different makeup than the sun. The star is much more turbulent. The surface is like a pot of boiling water. It's much more turbulent. And that drives strong magnetic fields on the surface of the star. And these magnetic fields, our sun has them, but they're pretty weak. These fields can cause what we call flares, which are these explosions that happen just above the surface, and material can sometimes get ejected outwards. And our sun does this from time to time, and it's usually not a big concern.
Right. That's how we have like northern lights.
Right, yeah. These high energy particles come off the sun and they can hit the Earth. When they do, they can cause cool things like the aurora, the northern lights. They can cause less cool things
like the 1859 solar storm.
1859 solar storm, or
We all remember that one.
it's
One of my favorite stories.
We were younger then.
I will let you take it away though, the 1859 solar storm.
Yeah, so this was called the Carrington flare, the Carrington event, and this was a very, very large flare that happened on the sun, and then they observed. So this flare was observed, and then 18-ish hours later, there were these massive northern lights that were seen as far south as like
Cuba.
Yeah.
And it was so bright that they were campers and they actually got out of their tents and they thought it was dawn.
Yeah.
But it wasn't.
Yeah. So it's wicked bright, and this was.
It's wicked bright, bro.
Yeah. and it's called Carrington event because it was just him, right? It was just Carrington looking at the
I think
sunspot.
he had an assistant.
Did he really? I
Yeah.
thought it was just him like making.
Carrington?
Richard Carrington. He was a British.
Yeah. Just some dude.
Sort of astronomer, like an enthusiastic amateur.
A guy with the set binoculars.
Well, that would have burned his eyeballs out.
Yeah.
I think he projected.
He had
right?
a projection of the
Projected
sun,
the
and
sun.
he would draw the sunspots every day.
Yeah.
And
this one was monstrous.
had been tracking this large spot when he watched the spot kind of like light up and move, and in the paper he says like, and I ran downstairs to get like Fred, whoever his assistant was.
Fred Weasley.
Yeah, right, exactly.
Yeah.
So the Weasley boys run back upstairs, and the sunspot has changed, and they weren't sure what they had observed. It was the first time this brightening event, this short duration brightening event, but they were actually seeing the explosion right by the surface of the sun. So anyways, these things are really neat.
Yeah.
And they're a whole interesting area studying themselves. Trappist, being a small star, has way more of them than the sun does. So not only are these planets 10 times closer to their parent star,
They're getting hit by these flares.
they're getting hit constantly by these flares. This star flares like 1,000 times more often than the sun. And the flares it produces are probably 10 to 100 times bigger than the flares in the sun. So this could be a real bad day on Trappist-B or whatever planet you happen to be standing on drinking your mojito.
Right.
This flare goes off in your face. These
Yeah.
flares can contain 10 to 100 times more X-rays than the flares we see on the sun. So these are really unpleasant events.
Yeah.
So much so that continued exposure to these events could actually chip away at the planet's atmosphere. So when we have a flare hit our atmosphere, it just makes it glow and it's pretty, and maybe messes with like the power grid.
Well, and our own magnetic field kind of protects us from the worst of it.
Right, exactly. If these planets didn't have any magnetic field,
They're screwed.
the ultraviolet and X-ray radiation could just strip away the atmosphere in 10,000, maybe a million years. Which on a geological timescale, on a life forming into complex life timescale, is
That ain't gonna
it's a blink of an eye.
And that's exactly what we think happened on Mars. So Mars's atmosphere, like I said, super thin today, hardly has any air around it. But we think that Mars was once a place with a more Earth-like atmosphere. Would have been thicker, would have been thick enough to have liquid water on the surface. We see the scars of rivers and ancient lakes that were there on the surface. So the atmosphere had to be thicker to have liquid water. But there's very little atmosphere now. What happened? We think Mars had a magnetic field that shut off at some point. And then after Mars's magnetic field shut
What?
off, you seen the movie The Core? Same
No,
thing.
but I'm worried about our magnetic field now. It could just shoot off.
Yeah, how does it just shut off? Like
So-
that's
We don't really know.
yeah. That's what I thought.
We don't really know.
We're all gonna die.
But because Mars is a smaller planet than the Earth, it's possible the interior has just cooled off faster than the Earth's. And in order to have a magnetic field, you have to have some liquid metal portion on the inner core of the planet, or the interior of the planet. And so once that liquid cools down and solidifies, there's no more inner dynamo, no more churning on the inside of the planet, generating the magnetic field.
Electrons need to move for a magnetic field to exist.
Yeah, exactly. So your metal needs to be liquid.
Right.
But we don't really know how that process happens, if it would have cooled off slowly, the magnetic field would have slowly died off, given all the Martians a heads up that something was happening, or if that's something that happens much quicker. What we do know is that the Earth's magnetic field switches polarities every so often, and that seems to happen really fast. So
It just happened, didn't it? Or is it going to happen soon? I remember
there's a lot of talk on the internet that it's going to happen, we're due,
Yeah.
but we really don't know. We don't have a good model for what causes these magnetic reversals to happen.
Right.
And we don't have a great model for how Mars's magnetic field shut off. And we don't have a great model for how the Trappist planets, whether they should have magnetic fields or whether they did at some point in time, or
And you could imagine if one of these things had a super strong magnetic field, a super duper
Yeah.
magnetic field, it could weather the storm of having these magnetic storms of the flares hitting it constantly. You could imagine
Right.
having,
constant assaults.
having a super strong magnetic field. If it could sustain that, maybe life could still exist down below there, and
Right.
have the atmosphere be held on.
Or if there's no magnetic field and the atmosphere gets stripped away and the surface of the planet is just getting bombarded with this harsh solar flare energy, then maybe underneath the surface is a place for life to weather that storm continuously. So maybe we have to continue our expansion of this definition of habitable zone to be deep down inside planets as well.
Do we have an example in our own solar system about having life be just under the surface, other than Europa, possibly? I think that's the only one I can think of.
So there are several of these large icy moons that might have liquid water oceans underneath.
Like Enceladus, right?
Enceladus, Enceladus is spewing water vapor out of its south pole.
Right, so we know there's water there.
There's definitely water there.
Yeah.
How much of it, how deep it is. But Titan is also a place where there is a liquid water ocean. So Titan's got all the craziness we've talked about on its surface, this hydrocarbon rain and lakes and these mountains and rocks made of water ice. But underneath all of that, there's a liquid water ocean on Titan. And so there could be some kind of biosphere deep inside Titan as well.
Gotta go fishing on Titan.
Yeah,
Totally.
and Europa, yeah. Mermaids, mermen.
But how do we...
Don't assume their gender.
I know, I shouldn't. But yeah, so I wanted to bring us back to the solar flares, because I think we've talked about this very little in other shows, but I'd like to talk about this more. Like, what would happen if there was the 1859 event? What would happen to Earth if we had a solar flare at that magnitude? Because the 1859 event, there were issues with electricity going through telegraph wires, and people were burning their fingers, and people were running the telegraph wires without any power because they were using the solar flare energy. But what would happen now? I love talking about that because it's really interesting, and space physicists love it too.
It's not, we call it space weather, because
Yeah.
like weather, we don't know exactly what will happen on more than like a day-ish time. You have models, but they're not really that good more than a day out. And you don't really know what the sun's going to produce and throw at you on any given day. So it's not a matter of, like so many things, it's not a matter of if, it's a matter of when. And in 2012, there was a large flare, probably about the size of the Carrington flare, that missed the Earth by like 3 days.
Oh, wow.
So it was enough of the energy hit several of our satellites. You could see the flare coming by. You could sort of see the wave of high energy particles going by, and you get this sort of a static, sort of on the end of the wave, if you will.
So you're saying that like it went off this way, and then the Earth was coming, and
Something
like
like that,
3
yeah.
days
Yeah, if it had
ago,
happened-
if we had been there, it would have been bad.
I forget if it was 3 days ahead of us or 3 days behind us
Okay.
in our orbit, but yeah, plus or minus like 3 days, it would have smacked right into us. And then it would have not been a theoretical
Right.
problem. We would have had a real big problem on our hands.
Right.
So when this event happens, like when the Carrington event hit in the 1850s, and they're telegraph wires. These long stretches of metal wire are perfect for what we call inducing current. And this is like a great physics lab where you can take like a light bulb and wave it around power lines. So if you go out into where these high energy power lines are, these big transmission lines, you can wave a light bulb around and it'll glow without being plugged in.
Or having an idea.
Yeah. Ding. So
Nice.
you can get that you can see that induction.
Yeah.
This is also how like your cordless toothbrush charges through induction, right? So you're getting electrons to excite through other wires. So when this flare hits, you get these wires chock full of electrons. You get a lot of current stuck into these wires all of a sudden that you didn't expect. This can cause a massive power outage. So you could imagine the power grid in, say, the entire Western Hemisphere being knocked out for a day or two, which would be an enormous, like a catastrophic economic impact.
Yeah.
$1 trillion impact, I think is what the estimates are, for just having the power grid completely shut down in like U.S., Canada, maybe part of Europe.
Yeah, and that's not even talking about the like satellites which would be affected.
Right. So potentially the GPS satellites, satellites that the military uses.
Yeah.
The poor astronauts. So the astronauts in the space station are above a bulk of the magnetic field, so they're getting sort of direct exposure. They have to go hide in their little lead-lined room and hope that they are protected enough from that exposure. And it would probably ground most air traffic. Boats in the ocean would have to like navigate by the stars because they wouldn't have their GPS systems. You can imagine like the trickle down, and worst of all, like television would be off.
Worst of all.
It's like it would be borderline unlivable.
Right.
At least for a couple days.
For a couple days.
I mean, how are you going to tweet?
Right.
How are you going to tweet?
No way to tweet.
No way to tweet.
Sad.
Yeah.
Yeah. References. So that's super interesting. I love that story. I actually tell the Carrington event story whenever I do like talks. I'm like, this is why science is cool, because electricity and magnetism is a hard subject even when you're a physicist. Like that was not my favorite class. I'm sorry to all my previous professors and my friends who teach it. But when you talk about an event like that, that really puts it into perspective that like we need to give a crap about this. We need to actually slightly understand electricity and magnetism to be able to prepare for these things.
Yeah, that's right. And we need to like study our own sun to make sure we understand how and when and why these things happen. When the Carrington event happened, they had like 12 hours, and they didn't know that that the flare and the aurora storm were connected at the time. They didn't know those were connected.
Right.
Now
we do.
We do know,
Yeah.
and so we're watching the sun. So
Yeah.
NASA has space telescopes called like Solar Dynamics Observatory, which 12 seconds instead of 30 minutes. It's much faster.
Improving.
Every 12 seconds, it takes an HD image of the sun.
Yeah.
And
Yeah, you don't want to look at it too long.
yeah, right.
I tried for 12 seconds. And
It's a long time. And from that, we are able to predict things that might hit the Earth.
Yeah.
And so what do we do if we make a prediction? What do we do with the few hours that we have?
Yeah, with 12 to 18 hours notice, what you can do is you can ground flights. You can turn off essential power grid items that would be damaged. You can
Hospitals. That's another.
yeah,
thing
right.
that
Get
they-
things on generators. Get generators ready. There's a lot of the power. They do see these effects in the power grid now. The power companies do monitor large stretches of the power grid for overloads, and so there's a lot they can do to sort of prepare the grid if they know this event's happening.
Yeah.
But even still, this is a point that the military, the government, civilian agencies, they all care about, and it would be good if we had a better way to communicate what NASA sees to the data that the military needs to prepare for national security concerns,
Right.
to prepare the Department of Energy and
Right.
what like civilian agencies need. We need a better way to communicate between these agencies.
Yeah. Well, and you were talking about the astronauts getting ready too. I've actually seen videos of them like, oh, an event's coming. Let's all get into our, So they get ready in this International Space Station as well. Also, when there's debris, apparently there's there's debris that orbits around, and like every once in a while they're like, it's coming again. Everyone get into their module because our space station might be ripped up any second now.
Big hole.
Right.
Yeah.
Right. So yeah, it's super
what kind of
interesting.
space stuff we got going around?
So there's space junk.
Just junk.
Yeah.
It's garbage. Yeah.
Yeah, there's, I don't know, does anyone know more about this than I do?
I mean, I know some of it is like leftover pieces from rockets and other launch vehicles. It can be like shards of metal or nuts and bolts, things like that.
Decommissioned satellites.
Yeah, old satellites.
Yeah. And there'll be things that like are broken apart or whole, and these things, if they're going fast enough, can rip holes through the International Space
Sure,
Station. So
right.
they have to like always prepare, and then in case it does happen, to like get out of their areas, and then in their spacesuits go and fix it.
Okay.
Yeah.
Sorry.
Yeah.
Just had to know.
No, it's really interesting because that movie Gravity, right? Like has like. I never actually watched the movie Gravity. We never watched it. We talked about it with Dr. Kobe. But there's like all the space debris, right? And it like hits her like continuously. Like,
Right.
but it's not that common, but it does happen. I wanted to bring us back though to because we want to wrap this up. We always talk about also pop culture, which I guess we were just talking about Gravity. But so
I've got another one.
you got it.
I got a pop culture one. This is what I prepared.
Yes. So yeah, this is what I always ask my guests. Is there a pop culture like reference to your work, and is it good or is it bad? Accurate or inaccurate? So
Okay, I didn't
that could
prepare
mean
that.
different things. But tell me your pop culture thing.
The pop culture thing I prepared was when the Trappist system was announced,
Yeah.
like earlier in the year, was almost exactly, plus or minus a few months, of when Star Wars, 1977, Star Wars would have reached, if it had been transmitted, it would have reached Trappist-1
Oh wait.
right about the same time. So it's 39.5 light years away.
So that broadcast would
So,
have
so
been.
if Star Wars had been broadcast in 1977, I realize it wasn't. It was in theaters.
Well, I mean, it
But if
was
somebody
on
bootlegged
TV.
a copy and put it out, it would have reached Trappist this year.
Coincidence?
Coincidence? I don't know.
So there's Tatooines over there. There's Hoths over there. Is what you're telling me.
Yeah,
Yeah.
that's right.
These are the planets in Star Wars.
Oh.
Yeah. I do like that a bit of trivia. But
Yeah.
so and we can talk about pop culture with exoplanets too, because like Star Wars has all these different planets. In Star Trek there was a whole bunch of different planets, but they all look like California for some reason. You know?
Yeah.
Yeah. But yeah, so do you want to kind of answer that question? How your field is portrayed in pop culture? Books, movies, TV, comics?
I feel like it's been portrayed a lot lately.
Yeah.
So I think in terms of like extrasolar planets, we've had a lot of movies lately, like Interstellar, was that what it was called? Yeah, Interstellar had
Love.
some. Yeah, it was a really, really cool film.
Yeah.
But some really artistic license, I think, with its interpretation of planets. So I was excited about the black hole that they showed. I was not as excited about the
planet
the
right
planet
next
around
to
the black hole.
I
Yeah.
know that was. We do talk about that in
Is
another
that the one
episode
that
too.
we watched together?
Yes, that you can check out our
It's a great
review of
flick, though.
Interstellar.
It's a great flick.
Yeah, but I agree that it was all kind of odd. It's
Yeah.
very weird.
Yeah,
have-
my problem with all the movies that have some kind of extrasolar planet or some foreign planet in there is that they're rarely creative. And not just in that they all look like Southern California, because
Right.
they're just filming
You know,
out in the
or
back of some
Vancouver,
lot.
BC.
Or Vancouver.
We got two options.
Yeah.
Vancouver, BC, or LA.
So my problem
the
is
desert.
that so BC and California, Southern California,
Yeah.
those are both on one planet here.
Yeah.
Our Earth is really diverse,
Right.
right? We have all of these different landscapes available.
Yeah.
But whenever there's a planet in a movie, it's always only one landscape, right? Like the Ewoks were on a forest planet.
Like everywhere's forest.
The whole sphere is nothing but forest.
Right.
And you never, and same with Interstellar.
Yeah.
You have ocean planets, and you have ice planets, and you have forest planets,
Right.
but you
Or you
never.
have the city planets that have all city, which is, I'm like, how do they breathe then? Like, where did the oxygen come from?
Right. You never have an actual diverse planet.
Right.
And so in my work, studying Mars for a long time was just thought of as the basaltic planet. It's just nothing but lava flows everywhere. And wherever you go on the surface has probably had more or less the same geologic history of some lava flows, and then it sat there and got busted up for 4 billion years. But what we're learning with the rovers on Mars now is that Mars was a really diverse place. And there was water some places and less in others, and glaciers in some places, and the water was highly acidic, like battery acid in some places, but in other places there were lakes full of neutral water that might have been good enough to drink. So there were all these varieties of types of environments that had existed on ancient Mars. And so I'd like to see that reflected in Hollywood.
Yeah.
Just some planet with more than one type of landscape on it. Please.
I just instantly,
To the people.
I just instantly thought of Middle Earth, of like Mordor and like Shire, and I'm like, that was just Mars, back then.
Yeah.
I'm sorry, too nerdy. But
Way too nerdy.
it's way too nerdy. I know. We're going to end with that. But I want to thank you for talking with us about planetary geology, and Jim to talk to us about kind of how to actually view these or find these exoplanets and flares. It's been super interesting. So thank you for coming to talk to us.
Yeah,
for having us.
Thank you guys.
This show was a collaboration between Western Washington University and KMRE Spark Radio. If you want to learn more, feel free to check out our website at sparksciencenow.com.